So, good evening, everybody. My name is Mait. I'm going to present about the HPC course at the University of Tartu that we piloted last autumn. So, a table of contents about things that I will be talking about. I will talk about why we even started giving the course in the university, how we did it technically, how we set up the topics, then about what we got right and what we got wrong and what we can actually improve on. A little bit about myself as well. I have been working in the University of Tartu HPC Center for 5 years now as a systems administrator. These days, everything related to the cluster, operating system and above is my main responsibility, and I manage all of that. So I am very integrated with the topics that we taught actually, and yeah. So first, we have had a long-standing problem that I believe many of you have faced as well, that the users might not really be interested in HPC trainings. They have their things, they have been working on HPC for a while, they just copy-paste their stuff, it works, and they don't care anymore. So getting them to actually learn how our stuff works has proven to be difficult if they don't have motivation about it. We even found a work group that had like an image of our cluster on their wall taped to it that was like 10 years out of date, basically. So that's when we discovered that we have a serious problem with that. But yeah, their things work, they were happy, and that's it. So we figured that we would need to give them motivation to actually attend the training, so some kind of a reward. So we actually created a specific university course. The idea was to get like the students who might be writing their theses and using the HPC cluster to actually learn how to use it. And a lot of our users are PhD students. A lot of them are professors as well. Well, they don't study anymore, they just use the cluster. But they can, in their work groups, they have PhD students, they can send them to the course, they get course points from it, they advance their studies. And at the same time, those same PhD students can go back to their work groups and tell them exactly like, yeah, this is a better way to do things, let's like switch over to it if they want to. So we basically created an HPC training, which is wrapped inside of an university course. So the course setup, it was 3 points, which is like 84 hours, I think, in total. It lasted the first half of the semester for 8 weeks then. We set up a weekly lecture where we talked about the topic of the week. The topics will be discussed later. And all of the teachers are staff at our own HPC center, so our own system administrators, developers who are specialists in the same topic that we are talking about. The seminars were held on site and remotely. But they were not mandatory in any sense, so they could come and just ask questions about the topic at hand. We didn't give any like extra information there unless they wanted to ask. The problem was that if you tell the students that something is not mandatory, then the attendance dropped like heavily after that. We decided not to do an exam at the end because the labs themselves are pretty thorough, and if you manage to complete all of them, then in our eyes it was enough. So, the technical side, we have quite a bit of expertise from other courses that we are giving. So, for example, we have a systems administration course that we also all teach that we have fully automated. So, we use scoring checks in Nagios for that. So, every user gets an anonymous name, so because they can see everybody else's progress, and with GDPR regulations, they shouldn't be able to see other students' progress. So, it has been anonymized. But with every lab or every week, we released new scoring checks. They can go into the scoring site. This is technically what they see. It's very red currently. But once they start doing the actual lab assignments, they start going green one by one. So basically, Nagios uses like bash scripts in the background that return a specific return code. And you can tell Nagios, okay, this is red, this is yellow, this is green. And on the right-hand side, you can actually display information that it will return to the student. So we have a potential to like make it more explicit to the users what's wrong with their current lab task. For example, if they almost have the right permissions on the directory, if they need to change it, but not exactly, then it can go yellow and say like, okay, you need to still do a little bit more. And they can go by their own pace. They don't have to ask us to like verify whether they've completed the labs. They can just go look at the scoring. If everything is green, then they're done. So there is no teacher input required on that part. So in that sense, it's almost infinitely scalable. We can have hundreds of students if we want to. So it isn't a problem to get more people on board with this. So it doesn't take too much of a teacher's time. So the HPC access, we have our own Waldor setup. So we wanted to use as much of our infrastructure as possible that we already have present, so we don't have to make up new things for it. Well, except Nagios, that we don't use anywhere else. We just use it for the course. So they get an invitation to a project, they have to accept it, and then they get access to the HPC, just exactly like a regular user would. And we had the course documentation in our own documentation website. It's still available publicly, and the students can refer back to it if they actually start working with HPC systems. And we had a separate Slack channel that the teachers are all in there, and the students are all in there. They can just come in and ask questions. And besides the seminars, nobody attended them. Students tend to work at like Wednesdays at 12 a.m. or something like that, and then they start bombarding you with questions during that time. But yeah, usually there we would answer their questions, they got their information, and that's that. Worked very nicely. So the course topics. We started them off pretty tamely with the introduction to HPC. We talked about what it is, and what it's used for, basically, a general introduction to HPC. This course wasn't really meant to be like the whole thing wasn't supposed to be like talking about HPC, but how to actually use it. So basically, the first lab was the only part where we talked about the HPC itself. But we made our lives easier. They basically use a shared project directory where all of the course progress is stored. That part is automated. But they have to get familiar with the command line, so we had them create their own scoring directories and stuff like that. So we didn't have to automate it, and they got their hands warm with the command line. The next one is one that I created using modules and software. So using just module load and running a command is really basic. So I put in spec as well, so they actually got to compile their own packages if they would need to do that in the future. The third was sharing, managing, and transferring data. So that's how they get their data into the cluster, how they get their data out of the cluster, how to do compression, not in parallel, because file systems usually do not like that at all. So just introducing them to best practices on how to move data around. Then we had running and monitoring jobs. So in the first lab, they also submitted a simple SBatch hello world basic script. So running and monitoring jobs, we went deeper into what you can do with Slurm, actually. We also introduced them to our monitoring stacks. So we have Elk, where you can actually go, and there's a visual dashboard which displays how much resources your job is actually using. So they can learn about that and how to optimize their jobs. So the fifth one was the description of ETAs. So that's our Waldor instance, introducing them to the different things that we have. So Open On Demand, Jupyter instance, RStudio, stuff like that. So they got to go in and play around with that. Problem with that one was that I actually was working on setting up our own on-demand instance at that time, and I finished it like a week after that lab. So we're a little bit late on that, but we can use it next year or in the coming fall. The sixth one was using containers and environments. They are pretty similar in what they do, so we could combine them really well. They got to use Singularity, they got to use Conda environments, how to build them, Python virtual environments. Those are really popular. So they got to play around with that. Now there's this spike in difficulty in that sense. They got parallel computing, so MPI, how InfiniBand works in a general sense. They got to run parallel programs across nodes. And the eighth is into the GPU computing, so they got to practice with GPUs, run their tensor programs and stuff like that. What we got right, the interest was surprisingly high. We expected like 20 students or so. At first we had 60 to 70, but a lot of them canceled the course at the start, which is okay, but we had 45 participants at the end. Most of them passed. I think there were like 3 who didn't complete the labs by the end. The software and file transfer labs were the most popular that the people enjoyed. The automated progress tracking, students really enjoyed that they could go at their own pace. Some complained that they lost track of time and didn't have time at the end, had to do everything all at once, but I see that as a student problem more than ours. But yeah, they had one deadline, easy. And yeah, they liked the pacing for the most part, which I will talk about in the next slide, which is what we got wrong. The main thing is the last 2 labs. Most of the students are not informatics students. Most of them haven't touched even Python before. They just need to run computational jobs for something. So if you start giving them a Python program that, yeah, run these tensor cores and do this and do that, they have no idea what's going on. Even the informatics students don't know what's going on there. Even we don't really know what's going on there. So that was a huge difficulty spike. So we had to keep motivating the students to actually do the last 2 ones. So yeah, if you have people from the University of Life Sciences who don't do informatics at all, they come in and they have no idea what's going on with like GPUs. They barely know what the GPU is. So. But yeah, that's something to fix. Having different lecturers, well, we had the different specialists give their own lectures, which was in that sense a good thing since all of our administrators got like public speaking experience. It was my first lecture as well that I ever gave, which was really nice. But different people have different styles, and if every week you get information differently, then it might get confusing for the students. Some explain things in more detail, some explain in less detail, and it gets weird at some point. And the checks, well, they're written by us according to the lab guides. So testing them is something that we could do more. So we have had issues where the student has actually completed the lab, but the check shows red and they ask us about it, or they bang their head against the wall and then don't think to ask, and then they come to us 2 weeks later about it. So yeah, there's better work that we can do there. What we can do better? Definitely think about the last 2 labs, how we can. We should probably just give them the programs to run and profile them and see how different things in GPUs or how MPI could help your jobs. The tests could be better always, and we could do more tour lectures. So this time we just in the lectures talked about the topic and all the practical things that they would be doing, but we could go more broadly inside of the lectures. They don't have to remember everything, but the more you give them, the more it sticks, basically, at the end. I think that's it for my slides. Thank you for having me here, and I think I can accept any questions.